Hello everyone. Today we are going to introduce our capstone design project, Itm전공. Here is the content. Due to the rise of online video platforms and social media, there's increased demand for short-form content. From the perspective of video creators, manually editing video and making highlights is inefficiency and demands a lot of time and resources. While various studies have explored different aspects like voice, images, and chat for creating highlights, there's been little focus on using emotions in this context. Therefore, emotional information can be an important factor in highlight detection. This first related research extracts visual semantics feature from YouTube videos and associates the implied emotional words with emotion knowledge graph. However, the downside of these studies is that it doesn't use audio. It relies only on visuals. The second research extracts features through feature engineering and concatenate them to detect highlights. It used LSTM as a highlight detection model. The limitation is that it is specialized for esports videos, so it is not suitable for general video highlight detection. We proposed a methodology for automatic extraction using a multimodal highlight detection model based on video and audio sentiment. The key is to maximize the emotional interplay between video and audio. We use a vision transformer to obtain the video features and wave to back to extract the emotion class, arousal, and positivity of the audio. And we optimize the performance of the highlight extraction model by using both features together. In dataset collecting method step to train VIT model for highlight detection, we used the YouTube video dataset from AI Hub, and for audio, we used Atris Korean sentiment dataset to train the wave to back model. In dataset feature extraction step, we used 250 seconds of video frame data to train the model and zero-pad the gaps. And the waveforms or MFCC processing was used to create emotion features. So highlight labeling was created with the majority voting. The model we proposed is a multimodal highlight detection model using video and audio emotional information. We conducted a comparison against two baseline models. First, we compared the unimodal model to see how the addition of emotional information affects the performance. Second, we compared the proposed model to a multimodal model using features without emotion information to see how it affects performance. So as you can see in the figure, here's what we did in our process. We decided to go with a feature that combines the image frame with the emotion extracted from the waveform. This combination served as the input for our LSTM multimodal model for highlight classification.
I will explain about our architecture. First, video and audio are extracted from YouTube videos. Next, for video, we extract features with highlight information using a pre-trained VIT model. And for audio, we obtain audio features with emotional information through emotion model we trained. Finally, we combine those two features and use them as input for a multimodal highlight detection model. As you can see from the table, in audio emotion classification, wave-to-back's F1 score was more than twice as high as LSTM. Likewise, in the case of arousal and balance prediction models, wave-to-back showed a much higher CCC. So, we can conclude that waveforms are much more effective at capturing emotional information, and wave-to-back was used in the final model. This slide shows the comparison of modal models according to the presence of emotion. When emotion information was included in the input data of the model, F1 score increased by 36%. The second slide is a comparison of experimental results for the multimodal model according to the presence of emotion. The F1 score of the model increased by about 30% when emotion information was included in the audio, even in the multimodal model. These two slides shows that we can detect highlights better by using emotional information. And this is the final comparison. Below is the performance comparison table between the highlight detection baseline models and our proposed model. F1 score of proposed model was 0.581, which is higher than the LSTM-based highlight detection model using only audio emotion and VIT-based highlight detection model using only video by about 16% and 50% respectively. And we summarized the makeup videos for 3 models and cut out the first 30 seconds. Firstly, I will show you the 2 unimodal models and then the multimodal models. So the left one is unimodal highlight detection model using only audio, and the right one is using video. And the left one shows too much information of cosmetics. Thus, there is no frames of cosmetic testings. And finally, it has very long intro. However, the right one has too much summarizations and cosmetics are not introduced sufficiently. And it has frequent interruptions in voice. And the next video is our proposed multimodal highlight detection model using video and audio emotional information. It has the normal length of intro, and it shows and compares those concealers and foundations very well. And in the last part, it shows cosmetic testings so we can understand how the cosmetics works very well. In conclusion, our novel approach proposes a new architecture for a highlight model. Our research can automate manual highlight detection, which significantly outperforms the model using only audio and audio emotional informations. Thus, future work is to develop a platform that we can reduce the user's highlight detection effort. And this is the references. Thank you for listening.